Compass Data, CompassDrone are proud to be a part of this inaugural event. Our friends at Connect Me have done an awesome job in taking this from an in-person, typical trade show type seminar that we would go to this virtual event in a matter of a month. And it's amazing. We're glad to be a part of it. In the pandemic world we live in today, this is becoming more common. There's what started out as a few, now are going to be a flood of these type of things, and it's important that the content and the focus be on the people that are attending and wanting to get and share information with our professionals in our business. The scope of our presentation has evolved as well as this event. Started out to be a talk about where drones fit, but when we started investigating that, there are so many other options today on how to collect data, and you just heard a mobile mapping from Cyclomedia and how they are extracting and collecting data on the street, and then drones and mobile mapping and pod and different imagery sources that are available today, and how do you fuse those together to get to answers. We will be asking you a few questions during the presentation and looking for some feedback from you as well. So when those survey questions come up, please respond with chat, and Ann on the other side is going to be giving us the answers to those questions. The goal of our session is to discuss the explosive growth of drone and mobile technology mapping and how those technologies fit in the traditional world of satellite aerial imagery that has been out there for many years. The challenge today is getting the right solution to collect the data, to populate asset management software, GIS, CAD, enterprise software solutions to empower decisions. What are the sweet spots for drone technology, mobile mapping, aerial platforms to provide the data needed to drive the enterprise? Accuracy and resolution requirements for asset management, design, build, environmental and regulatory compliance drive the need for different imagery and LiDAR sources. Our goal is to meet organizational requirements with one solution for engineering, GIS, environmental, and operations. Collect it once, use it for many different functions. Delivery of large data sets are a challenge to deliver in a format that's easily ingested in software platforms. Over the years, it's getting better, but I've seen large transportation organizations put LiDAR on their vehicles, in the case of train, and collect their entire network. And it's still sitting in the cabinet in data storage and never been processed or used. So it's about how we take this data and deliver it to the point of decision. And define processes in such a way with future updates and data maintenance, you can add to what you built on to make it better. On the solution side, drones and mobile mapping provide opportunities, changing the way we look at projects and power efficiencies and versus traditional on-the-ground surveys. Using the right acquisition solution to give accuracy and resolution needed to meet program requirements. A combination of survey, ground survey, mobile mapping, wearable backpack mapping, drones, pods, broad aerial fixed wing and helicopter collection, and satellite imagery all can play a role in solving the problems and feeding the information into a software platform that drives AI and other intelligent solutions. Accurate survey control, which is close to our folks at Compass Data's heart, is a key to making these data fusion projects work. A lot of these solutions have IMUs and ways to do it, but the IMUs cannot be consistent in urban canyons. You need to have control to get to the most accurate solutions. Delivery. Once you have this data, how are you going to use it? There are more and more every day are groups of organizations that have web-based delivery and cloud-based delivery of data that's collected and used to make decisions versus delivering data to you that ends up on a workstation in your shop. You need to understand how the data is going to be delivered and used to make those decisions. You need to define a process to deal with updates, support, and features to result in the base data being used for change detection as well. That should be part of your solution. Next. Who are we? The Compass family of companies have been around for 26 years. The three businesses we're going to highlight today, one is CompassCom, a GPS tracking solution that's used for enterprise-based tracking on an Esri platform that has primarily been used in public works, local state government, customers like Illinois DOT for tracking 1,800 snowplows across the state, as well as City of Fort Collins, who presented earlier, has used our solution for years for snow fighting, U.S. Capitol Police, the Mexican military. This is an Esri-based platform that is used to do real-time situational awareness and command and control. Compass Data and CompassDrone are the focus of the conversation today. Compass Data is a service company that provides, primarily over the years, a leader in GCP collection and archive generation, as well as mobile mapping and drone mapping and pod mapping. We work from the ground up. There are many of our partners and friends that own aircraft and our partners that own satellites that can provide that data. We fill the gap from the ground up to those. CompassDrone was championed by my son Hayden Howard 5 years ago, getting into the business with DJI and other sensors to get into the drone business. And as he says, drone years are like dog years. So we've been 5 years times 7 in this business, and the work that we've done to understand the software, understand the solution, what works. And the synergy between the drone business and the Compass Data business is paramount. On synergy to CompassCom, it's unbelievable that there are organizations that do not have good base maps. And Compass Data builds the good base maps needed for things like refineries, defense organizations in the background of our tracking solution. A heritage of success. We've worked with the big players providing ground control and solutions over the years. From our friends in France and Airbus, and our friends up in Longmont and Maxar and all the way across the board, Google, Microsoft, Vexel. We have a success, and even our friends at Cyclomedia we're working with as well that were just presented. So we have the heritage and experience to make these type of programs successful. We're ISO certified, ISO 9001, 2015. Our processes reflect that standardization. And we're also FAA certified for producing avionics grade mapping products that end up in the aircraft. Some of the projects that we're going to talk about today relative to the technology is drone collection of archaeological sites in a right-of-way. Drones offer a very unique perspective to be able to do this versus traditional collection methods such as ground survey mapping with resource grade mapping receivers, things like burial mounds, ditches, campfire rings that may end up in a power line right away. Drones can be a perfect solution, either drone imagery or drone LiDAR. On the utility side of the business, we're doing more and more backpack mapping of transmission and distribution corridors, places where you can't take a vehicle. We are doing work with LiDAR backpacks, and those backpacks are used to generate imagery as well as point clouds to determine vegetation encroachment, to be used on line sag, and also to be used for new design and development in the power industry. The most amazing thing that we've done over the years has been our GCP archive of off-the-shelf ground control available for delivery for folks that are producing geospatial, remotely sensed products, or QA and QC those products. That slide you saw of the logos, many of those clients use our ground control to produce their products today. We have over 60,000 ground control points we've collected over the last 20 years in over 100 countries. That's unimaginable. Think the amount of time and effort it has took to do this. And when you wake up and think about it, it's amazing. Those are processed with standard ISO processing, approved processing, and the consistency, the geodetic accuracy as you go across the globe, based on our professional surveyors and photogrammers we have in-house, make this a very unique data set that enables clients to build better products. this resume gives us a very strong position to provide an end solution to customers that need accuracy and consistency. So the first question we're going to have today when we talk about drones, are you using drone technology in your projects today? And we'd appreciate if you respond back and let us know how you're doing. Drones, like any new technology, are the shiniest penny on the block. Everybody wants to use them, trying to figure out. But drones aren't always the best. They may be the best solution, they may not. So we've been through a lot of that in our drone dog years, and we think we have a unique insight on how best to send clients to the right solution. So if we can get those results up, and in the meantime, I'm now going to switch over to Andrew Carey, our Director of Business Development for CompassDrone. Is going to share some more technical details about what we're doing.
Thank you, Brand. Looks like we're having some questions there answered and coming in the live poll. So my name is Andrew Carey. I'm Business Development Manager for CompassDrone. I'm also very much in need of a haircut, and I totally understand. I'm sure lots of you are in a similar boat right now. I can't wait to look forward back to this presentation and take a look at myself on the recording. So looking forward to getting myself back into a normal haircut world. So I'm going to take a little time here, and I'm going to go into briefly talking about some of the hardware platforms that we may approach a particular client with in a discussion. So this is an overview of the capabilities that are in our portfolio that we may discuss with you as a potential client. I do want to get started playing off of Brand's topic there about what it is that you may need. So the drone is a new shiny tool in our toolbox, but the drone may not be the best solution for your particular use case. When I go into a client or a consideration for a topic of discussion for a collection, some of the things that I may bring up that I think would kind of funnel into what might be the best solution for your particular project. Some of the things that we would consider in a conversation are going to be right out of the gate, talking about what is the size and scope of your area of interest. So when we're looking at a project, are we talking about a county, a state? Are we talking about a particular construction site? Are we talking about change over time in a corridor? If you're a DOT and you have a project site or a construction, what is it that you're most particularly interested in? And that's going to really dictate some of the hardware platforms that we might use for a geospatial collection. We may also be talking about the resolution and the accuracy of your collection. So when we go and we talk about what it is that you're looking for, we're trying to figure out what it is exactly you want to be pulling out of that data. LiDAR is a topic that we're going to talk about here in a minute, but LiDAR may not be the best solution for you depending on what your needs may be. And then the data ingestion is a critical part to this conversation. So as Brant mentioned in that LiDAR train analogy story from earlier on, we want to make sure that the data we deliver is going to fit your systems, your final production methodology. Are you trying to meet compliance, environmental concerns? Is it an asset inventory? Do you just need a pretty picture? Is this going to a project manager? Is this going into a GIS or CAD department? We want to make sure that we're meeting your accuracy requirements, your specs for your project. So we're going to talk about how the data is getting ingested. And then of particular note here, I do want to take some time and talk about the timing and regulatory issues associated with using different types of systems. We may not be able to use a UAV given the particular regulatory requirements of the FAA and our Part 107 regulatory operation requirements. There are scenarios and stories that we can tell where we have used a UAV where it was a very difficult compliance requirement that we had to submit specific paperwork in order to use one, but those things take time. So if you're a client and you have time constraints and you have delivery timelines that you're trying to meet and you want to get data in-house, you may not have the ability to wait 90 days for the FAA to get back for approval on a system. And then there at the bottom right, if you're looking at a crowded area where there's lots of people frequenting, what is the timing of your collection? Are you looking for a flight or a mobile mapping collection every month, every quarter, every week? Are we looking for change over time? What are the practical abilities to using a type of system to fly or to collect for the mobile mapping system? So those are some of the things that we may talk about. One of the goals of this presentation is to sort of give you some feedback and some primers to help you understand when you may be able to use a particular type of system and what kind of implications there might be to picking that system. I just want to have a quick conversation about accuracy and resolution to make sure we're on the same page and talking about what these two things may mean and what they may mean for your collection. So for when it comes to accuracy, I have Esri to thank for that image slide there. We are a ground control company. So any data that we produce, we want to make sure, is this a one-off? Are you just looking for a construction site update? Are you going to take our data and you're going to integrate it and lay it over with other types of data solutions? Are you planning on giving this data to the GIS department? Are they going to overlay their maps on it? If they are, or if they're planning on sharing this data, we do want to make sure that it's in the appropriate projection system, coordinate system. We want to make sure that the data lines up, that the expectations are set with the accuracy that you're asking for. It sort of controls how we would go about laying control, establishing control, and then processing and producing documents associated with that data so that you can share it with other folks and they can feel confident that that data is going to fit their need. And then resolution. There's an image there from a construction site that I want to pay particular attention to in this conversation because I think it tells a good story. When we're flying a UAV aircraft, we have the ability to change the altitude, speed, the overlap. We have a bunch of parameters that we can change around. In that larger picture there, you can actually count the rebar caps there in that concrete frame that's being poured. So some of you folks probably know how big a rebar cap is. That's a pretty fine fidelity of resolution in order to be able to pull that feature out if that's what's most interesting, if that's most pertinent to your collection in an area of your concern. If you're not looking for something that small, the image on the right there, that's from a satellite image of a small town in Nebraska. That's about the max resolution you're going to see in that picture. So you are going to see things like sidewalks and buildings and cars, large objects. And the little story that I like to tell here is that I think is funny is we get clients asking us to max out resolution and accuracy and all these points per square meter for LiDAR. And my colleague Mitch Tweedy always has a really funny response, which is, did you lose your car keys in that random field out that we're going to fly at 50 feet and as slow as we can? So what is it you're trying to do? We want to make sure we fully understand that so that we're using the appropriate equipment and technology to deliver that. I'm going to briefly go through here some of the hardware platforms that we have in our portfolio and generically kind of talk high level about them so that we're all on the same page and we understand what systems we might present to you as an end client. So when it comes to mobile mapping are camera LiDAR systems that we're going to mount to some type of vehicle in order to rapidly collect and deploy a geospatial collection tool. But some of the limitations, as you'll see in a chart here in a minute, some of the limitations are that these systems are mounted to vehicles. So we're looking at pulling off features associated with linear collections, roads, right-of-ways, anywhere we can operate a vehicle without damaging the end product. We also may integrate the two solutions together. So in the bottom right there, you'll see a mobile mapping collection project that we did where we were pulling out specific features. The end client was particularly interested in poles, vault boxes, electrical utility, manholes. This was an infrastructure study. But we also had the capability of flying an aerial image. And what we're able to do, because we are a control company, is integrate the two things together so we can provide all that context to that product so they can share it around, make their maps, print them up, hand them to project managers, hand them to visitors, or anybody doing work at the site. So we double dipped there the information. We provided an aerial image along with the mobile mapping to pull all the features out pretty quickly for the client. UAVs, obviously this is a CompassDrone presentation and we're talking about the hardware and systems, but I do want to emphasize the fact that we are a DJI Enterprise hardware reseller, so we do get first crack at a lot of the systems coming online. We have a great relationship with DJI. And I don't know if you guys had seen, but last week the Matrice 300 was released. And I really thought it was pertinent for this conversation to focus on two unique hardware-software combinations that are coming online for the folks participating in this conference. So AI Spot Check is something that's coming online that is of particular interest, I think, for asset inventory. What it's doing is it allows an operator to trigger a position for the camera system on the UAV to take a particular image. And then that position, that orientation of the aircraft, camera, distance can be repeated. So that means a different pilot can show up. That means somebody can show up down the road and actually trigger that button to have the UAV fly right back to the position where it took that picture and take subsequent pictures in the exact same orientation, direction, so that you have a repeated still picture over time. It means the pilot doesn't have to worry about framing the picture appropriately or making sure they're getting all the elements that were captured the first go round. One of the other unique features that was released last week on the ZenMuse H2O camera is also an inspection element that I want to focus on, which is this idea of combining wide-angle cameras and high-resolution zoomed-in pictures. So it allows us to take a picture of something, and then you can take it from a safe distance while operating the UAV, and then it's also going to simultaneously take zoomed-in pictures. What this really means is that you're going to be able to take a wide angle picture and get context, and then you're going to be able to use the software to go actually dial in, zoom into a particular feature that you may be interested in and make sure you're not losing any of that resolution or fidelity to pull out what's most interesting to you. LiDAR, obviously, this is a burgeoning topic and a newer technology, and there's a lot of different mobile mapping systems that are mounting LiDAR systems. We own a Regal Minibux that we mount to a DJI M600 for UAV collection. There are LiDAR systems on aerial-based platforms. We use this technology when we're fighting things like vegetation penetration for terrain modeling. If there's thick vegetation, photogrammetry is not typically a good solution. If we're looking at inspection and we really need to pull out the accuracy and fidelity of a particular element on something, we're going to scatter that thing with LiDAR points so that we can really see what we're looking at. And then we also do have the LiDAR backpack system, which is easy to deploy if there are regulatory concerns, timing concerns, line of sight concerns. We're able to get anything up to, I think I've seen up 700 points per square meter on the backpack. It's absolutely crazy. So that's something that allows us to really diversify our collection of geospatial data. Full motion video, CompassDrone developed an app a couple years ago so we can actually fly an aircraft and record a video file and play that video file back inside an Esri platform. We can pull out geospatial features so we can see the direction, the bearing of the aircraft. We can see the footprint of the camera. Full motion video is not a solution that maybe would fit every bill, but if we're talking about things that are moving around or changing over time, or one of the best scenarios is a service contract that we have where we are doing photogrammetric flights. We're flying the aircraft and producing engineering GIS assets. We're pulling those features out for the GIS department, and they're getting the data they need. But one of the concerns they had was they wanted to showcase that data to their end client, and a video file was a really simplistic way to show at the end client how things are progressing at that site. So if a picture tells 1,000 words, a video might tell 1,000,000. And then the ability to see the aircraft on a base map, what direction it's heading, what it's looking at in that video file really tells another story that might be helpful for folks considering using a drone for something. And then very briefly here, the mid and large scale solutions for collection that we have. Brant mentioned, we lovingly call it the pod system. It's not very flattering, but it is a camera system that mounts to Cessna 172s and 182s. It's a small compact system. It allows us to ship it around the country. We can pretty typically find an aircraft just about anywhere that we can mount that system to. We can deploy it quickly, and we're looking at, it's a supplement to our drone image collection services. So if we're talking about 2 to 3 centimeters on a drone, we may be able to get 5 to 7 centimeters on a low altitude fixed wing system. Allows us to cover more ground, overcome regulatory obstacles that we may face, scale flight efficiency collections that we may face. And then also satellite imagery. So satellite imagery is a really, really useful tool for base map supplemental cost-effective aerial imagery. Our ability to resell from our satellite partners really add to our portfolio, looking for supplemental imagery base maps to their projects. So it's a cost-effective alternative to other type of image systems. So Brant kind of hit on it there. I just spent some time there rambling about hardware options that we have in our portfolio, but I want to take a second here and talk about what type of conversation we would have and why these types of hardware platforms are just part of the solution. So when we talk about beginning with the end in mind, we have Stephen Covey to thank for the idea of understanding the end results and where we're going with these systems and how they're going to deliver the solution you're looking for. So when we have conversations, we're going to talk about the file consumption at your organization, what you're looking for. Are you looking for data in a particular format, in a particular data dictionary? We're going to ask you questions about what type of data and projection system, coordinate system, epic you're looking for the data to be delivered in. And most importantly, we're going to provide transparent reports on the accuracy of the data. We are not a black box organization. We have 1 foot in the past and 1 foot in the future. We're looking at this technology and evaluating it and handing you reports that meet industry standard ASPRS guidelines as far as what we're providing the data and what your expectation is. So we work with our PLSs to submit reports and data that you can feel confident sharing within your organization to make sure we're meeting your specs. I apologize for the eyesore of this chart data, but I want to quickly kind of figure out and showcase what we're talking about when it comes to what types of solutions make the most sense, because that's why we're here today at this conference. So starting on the far left there, we break areas up into small, mid-large, and large. We have different types of systems that meet different types of accuracy specs and requirements. We have systems that can penetrate vegetation, that can look at ground assets. We want to be concerned with the data load and how much data we're sending over to you, and then what type of regulatory obstacles every system potentially might have on a collection. This chart, I'm happy to share it with anybody that requested. It is our generic solution. Obviously, there are fixed wing UAVs and long battery life solutions and all kinds of people in the marketplace, but we need systems that we feel confident in, are repeatable solutions that are consistent with the methodologies that we're providing to our client. Specifically there, the UAV RGB down arrow half circle that's unique there. That's the reason that symbol is there is I want to make sure you guys, that everyone in the conference understands that using a drone can be a very light load. You can take a pretty picture from above, or you can take a video file and share it, or we can lay control. We can use traditional survey methodologies and lay a lot of control in that project. And we can process checkpoints and GCPs on that, and we can start to understand the accuracy of the ortho products. We can start to generate 1 foot contours and topos, and we can start doing lots of things with that data. But without the robustness and understanding the control and how it's distributed and laid out, we're not going to be able to provide that to you. So there's some variable options there. So I hope that was helpful. I'm going to ask you guys here a quick survey question and try and figure out what type of accuracy levels you would think you would expect you to need on your projects. And with that, I will conclude the hardware solution section and hand it back to Brant for some final thoughts.
So as we talked, as you answered the question here, you may have multiple needs with a single program. Where in an engineering side and topo side, you may have a requirement, but you want to have the resolution on what you collect to be able to extract assets and do some feature identification. So the accuracy levels that you pick may be just for your particular part of the program, or it may be something that will serve the need of multiple programs. So if we could share some results, what we're seeing.
Oh,
Wow. Everybody's down in the hot stuff here. That's great. That's great. So if we were to take that and go back to our graph where we were before, depending on the size of the AOI you're using, then mobile mapping and LiDAR and drone LiDAR might be the solution for this graph. Okay, can we share the results of the previous question as well? Can we go back to that one? I know we sort of went through it quickly. So yes, we've got 16% are using drones often, occasionally, considering, and 20% no thank you. Okay, that's good to know. All right, so let's move on to, I'd like to give an example of this data fusion where we recently did a program, and what we need to talk about too is data outputs. Being able to use the points we've talked about, survey, repeatable, consistent, and accurate control to empower the fusion. Also, imagery and LiDAR for multiple platforms to get to a complete solution. And then plug and play delivery to the enterprise to get answers without multiple steps. Working with the folks you work with, many of the people that are end users don't want the pain of having to go through large data files to get it in and put in a system to make it happen. You should have a plan to make that happen as part of your acquisition process. Control and standard process, ensure integration, future updates and end users. We always talk about how we do the updates and what we're going to do in the future with the data we have. Many of the softwares you see on the bottom are enterprise-based software that take this data and provide answers. We've been an Esri business partner for 26 years. Many of the folks in DOT use MicroStation. We also are partnered with Orbit GT. We're going to talk about them in a minute. Our friends at Autodesk do a lot of design work. Drone Deploy we're partnered with as well in delivering, helping them deliver solutions through a cloud-based platform. So pick the data outputs and the interface for your end users that make sense. Next, please. This is a great example of data fusion using multiple data collection methodologies to get to the end of a project. Winter Park, the resort of Winter Park and the town of Winter Park approached us over a year ago about doing a project with drones to do 3D surface elevation models and imagery. In a further discussion of it, we found out drones really weren't the right solution. The area was too large, the elevation was too extreme, and we ended up picking a combination platform. It was actually like a platform that was used to do the imagery, the oblique imagery, as well as the LiDAR. The key to making this project work was the multiple tens, I'm not going to tell you how many, grounds control points that we established on the project area and the AOI as well. We also have updated their monumentation in the valley that had been done over many years by many different methods and was inconsistent. So we started from the ground up, getting the monumentation correct, providing control that would enable us to process the LiDAR and also the imagery to produce the 3D elevation models and surfaces that you see here in these pictures. What was really unique about this is Winter Park is, with the investment recently of being purchased by a large ski corporation, is using this data now to plan for future development, also for environmental purposes. And there's a company called Pits and Bowl that builds a automated snow management system that does automated snowcat, almost like intelligent farming, on the mountainside to enhance the skier's experience and also be more efficient with snowmaking and water production and use of water in snowmaking. So Pits and Bowl wanted this 3D surface to put into their back end to enable them to do this automation. So this project not only used control on the ground, airborne, we also did mobile mapping of the villages for asset inventory, and we are going to use drones in the future. The drone LiDAR systems will be used to do new lift corridors and add and do this update and management of the system as we've talked back in the past. This project was completed in a 3-month time span and delivered. We had a very short window before the snow started falling again. But this is a really good example where multiple technologies came together to produce answers. This is being used by the town planners, people on the engineering side, people at Pittsburgh to do management and operations of the ski operation in the town. Next. So we're going to follow up one last question. How would the data best be delivered to work for your typical projects today? And then if we answer that question, then we'll go to the Q&A side of it as well. Are you looking at a web-based delivery? Do you want the raw data delivered for you to process? How do you typically like to see the data delivered to you? We'll give you a minute while we get ready for Q&A. We're getting results on that end?
We have 26% of the people having currently voted. If you'd like to vote, go ahead and vote in the poll. I can end it and give you the results.
And Gavin, why don't you ask a question while we wait for some of the results to come in?
Sure thing. We had a couple of questions come in. Some of these might be best asked by using the link in the guide to book some time with you or Andrew directly, because they drill a little deep. But we had one question translated from Spanish from Omar V. Could you demonstrate how to get georeferenced images using PPK and RTK? Which one is more reliable? What happens when the image is not georeferenced? Probably have to go offline with that, but if you could,
I think Andrew can give you an overview on the drone side, what we're seeing there.
So when it comes to the PPK solutions, I have trying to keep my finger on the pulse on all the changing technology, and I'm hearing a lot of folks really excited about the PPK methodologies, and we are internally doing some research on them. We have kind of a hang-up issue. We have kind of a hang-up issue with PPK, and it sort of goes to contrary to the surveyors and the traditional methodologies that our folks are using here. The thing I've heard about PPK that is the most nerve-wracking is this idea that you don't need control, you don't need checkpoints. Don't worry, we've done the testing, the solution works. Engineers don't typically like to hear a pat on the back and a, hey, go ahead and trust us, it's really, really good, or our system works really, really well, and it goes in and it spits out the right answer. That's not typically the way surveyors want data to be presented to them. They want to follow systems that they can work math backwards, they can see the transparency of the checkpoints, they can see the delta shift between where a survey point is in the image and where it might have moved to in the photogrammetric processing. So we typically are using more RTK type solutions in our aircraft. So an RTK solution, if there's an existing VRS network or some type of network that we can reach through an IP or a cell network, that helps us a lot because it streamlines not just the collection. It doesn't eliminate the need. We're still using ground control points and checkpoints to provide data to our clients. But with the connection to a RTK network, it means that the position of the aircraft when it's taking pictures is much tighter, which means that the products it produces and down the road as the products are being processed, everything tightens up. But I hope that answers that question. I know that was kind of vague, but the PPK stuff, we're trying to do some internal research and understand a little bit better and present it, but it makes our folks nervous to just say, trust us. So we don't do that. We want to provide data over to folks that are as transparent as possible.
Okay, thank you, Andrew. There was also a question, somebody would like you to post up a link probably in the chat for the aircraft pod option. I think they're discussing like the Waldo pods or generically. So we have a question, and then Ian, if you could queue up the results of that poll. But a quick question from someone was, why are drones a challenge in hilly terrain?
Hilly or high altitude or both?
Both, I guess. Yeah.
So there's a couple ways to answer that question. From the regulatory standpoint, so we are required from a very basic, just off the shelf, Part 107 remote pilot certificate. We are required to maintain line of sight of the aircraft. So when we have variable terrain, we sometimes have a challenge positioning ourselves so that we can maintain compliance with that regulation that we are maintaining line of sight with the aircraft. That's one challenge out of the gate. The other one is maintaining consistent altitude and not having variable pixel size. When we're at the top of the mountain, the pixel is going to be a particular size, and as we fall off, we're going to see a significant degradation in the pixel size, and we're going to have two pixel sizes trying to process those simultaneously. That's a challenge. We can mitigate that challenge with a terrain following flight collection software, where we're importing an elevation model, and so the aircraft will maintain a consistent altitude. We do that with our LiDAR system. We use a particular software version from UGCS, Universal Control Ground Station, where we're importing a NASA SRTM elevation model so that the aircraft maintains a consistent altitude so that our point density as we're changing up and down is not drastically all over the place. So those are just one of the solutions that we might use.
So it looks like we had about an equal preference on delivering the process data and also delivering it for on-premise use. So there are a lot of new platforms coming out that are web-based, and so we'll see how that trends over the next few years, if people will depend on a web-based delivery in the cloud. So that was a result of that. Next question, Gavin.
That's the end of those questions, but there was one related to a previous session that we could cover with about a minute of an answer. Someone asked, and later we could ask Jason a bit about this as well. The ability, because you do mobile mapping as well, the ability to recognize pavement distresses and calculate PCI.
I think those type systems, a lot of the LiDAR-based systems give you better results on inconsistencies. Pavement on runways, pavement on highways. You can use photogrammetric systems as well. There are vibration sensors on these big collection vans that go down the road to collect as well. So it would have to be tested to see what would be the best solution for the different type of applications. It's not in our field of view that we do a lot of that, so we're probably not the best one to answer that question.
Okay, I'll bring it up again in the later in the coffee break session at the end. But Andrew and Brant, thank you very much for this really insightful presentation. To keep on the schedule, I'm gonna move over to the next one, and look forward to hearing more from you guys in the future as well.